Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields, and today's lecture topic is Biot Savart Law from Unit 3 Magnetostatics. On completion, the students will be able to derive the expression for Biot Savart Law, list the applications on importance of Biot Savart Law, and also solve some sample problems in Biot Savart Law. Biot Savart Law. The Biot Savart equation expresses the magnetic field created by a current carrying wire. This conductor or wire is represented as a vector quantity and is called the current element. The magnitude of magnetic induction at a place caused by a thin element of a current carrying conductor is stated in the law, which is found to be directly proportional to the current, directly proportional to the length of the element, directly proportional to the sine of the angle between the element and the line joining the center of the element to the point, and inversely proportional to the square of the distance of the point from the center of the element. Derivation. Consider a conductor of any form carrying a current I and a tiny length element dl. The current flow is depicted vertically upward. Let P be any point at a distance r from the current carrying element, and r be the position vector of P with respect to the current element, and theta be the angle between dl and r in the direction of the current. According to Biot Savart Law, the magnetic induction at point P is given by dB is equal to Ki dl sin theta by r square, where K is a constant and its value depends on the system of units and also the medium in which the conductor is situated. In the SI system, the constant K for vacuum or air is written as mu naught by 4 pi, where mu naught is called the permeability of vacuum or free space. And substituting the value of K in the previous equation, we are getting dB is equal to mu naught by 4 pi into I dl sin theta by r square. The SI unit of mu naught is Weber per ampere and its value is 4 pi into 10 to the power minus 7 Weber per ampere. The direction of magnetic induction is perpendicular to the plane of the figure and is directed inside the plane as per the right thumb hand rule. In vector form, we shall write the above equation dB vector is equal to mu naught by 4 pi I dl vector into r vector divided by r cube, where r is the vector drawn from the center of the element to the point and dl is the length of the element in the direction of the current. The total magnetic induction at a point P due to the entire conductor is found by adding the contribution of all such element and is expressed as B vector is equal to summation of dP vector, which is given as mu naught by 4 pi summation I dl tends to 0 dl vector into r vector divided by r cube. The summation being replaced by integration, we get B vector is equal to integral of dB, which is mu naught by 4 pi integral I dl vector into r vector divided by r cube. Now, the magnitude of the magnetic induction due to an infinitely long and straight conductor carrying a current I at a point at a distance a from the conductor is given as B is equal to mu naught I by 2 pi a. Applications of Biot Savart Law. Following are some important applications of Biot Savart Law. Biot Savart Law can be used to determine the magnetic responses at the atomic or molecule level. It may be utilized in aerodynamic theory to determine the velocity promoted by vortex lines. This rule may be used to compute the magnetic field produced by a current element. Importance of Biot Savart Law. Following are some importance of Biot Savart Law. In electrostatics, the Biot Savart Law is analogous to the Coulomb's law. The legislation also applies to extremely tiny conductors that convey current. Sample problems. Consider a long straight wire carrying a current of 35 ampere. What is the magnetic field B at a point 30 centimeter from the wire? Here, the given data is current is given as 35 amperes and the value of A is 30 centimeter, which is equal to 0.3 meter. To find the magnetic field, the formula is B is equal to mu naught by 2 pi into I by A. And B is given as 4 pi into 10 to the power minus 7 divided by 2 pi into 35 by 30 centimeter or 0.3 meter, and it is written as 2 into 10 to the power minus 7 into 116.66, where B is equal to 233.32 into 10 to the power minus 7 Tesla. The magnetic field at point 30 centimeter is obtained as 233.32 into 10 to the power minus 7 Tesla. Quiz questions on Biot Savart Law. Write down the expression for Biot Savart Law. What are the applications of Biot Savart Law? Give the importance of Biot Savart Law. A long straight wire carries a current of 35 ampere. What is the magnetic field at a point 30 centimeter from the wire? Thank you.